Hello everybody and welcome to the null hypothesis video. Um, I wanted to make a short video about a null hypothesis because there's been confusion in the past in terms of the video. I wanted to give you some examples of what we expect for a null hypothesis because the directions I apparently wrote were not the greatest in the world. So if you look at the background information, this is the document that's in this week's material. A null hypothesis basically means that there's no difference between whatever the variables are that you are looking for. And the confusion comes in if you look at this document. It says the null hypothesis is for a the null hypothesis for a chi-square analysis is always the same. Any difference between the observed and expected data is due to chance. Now that's true, but this isn't really what you're supposed to write when you write a null hypothesis. Okay, so the goal is to refute this because you would never really do an experiment if you thought there was going to be no difference. That doesn't really make any sense at all. But the idea is if you come up with a difference, then you have something concrete statistically that you know there is a difference for. Okay, so let me give you some examples. So I found a good website that had some examples of different null hypotheses, and this I thought was a really good way for us to write our null hypothesis. So if you look here, it basically says that you take whatever your question is. So for example, here we have a list of questions. This first question is, are teens better at math than adults? So you take that and then you turn it into a null hypothesis. And the null hypothesis would be something to the effect of age has no effect on mathematical ability, or teens are not better or teens are not any better at math than say adults. Okay, so it doesn't necessarily have to be perfect, but you have to get the idea that whatever the variables are that you're testing, there's not going to be any difference between those variables. And the problem with this right here is it doesn't tell you what the variables actually are. So you need to include your variables. So for example, in this first week's experiment where we're dealing with color distributions in M&Ms, you need to talk about the color distribution. So the question we're basically asking is there a difference in the color distribution of M&Ms? Okay, so you have to come up with a question that has to do, or you have to come up with a null hypothesis that has to do with that question. So a couple other examples that they have in here. Let's do the cat one because I happen to like cats. Do cats care about the color of their food? So cats express no food preference based on color. Okay, so cats don't care about the food. Now, like I said before, that doesn't mean that cats don't care about the color. It's just a way to write it so that you can try to disprove it, okay, using the statistic. And that's what statistics are all about. Do you have a number that can actually show that there is a difference between these two things so that you're not just saying, yeah, there's a difference between these two things? Okay, so that's the difference between using a statistic for something and just looking at two numbers and saying, yes, there's a difference between these numbers. Because it's important to know, is it statistically different or are they just different? Because if they're just different, that doesn't necessarily mean that they're different enough for it to actually be a difference. Okay. If you have any further questions about that, feel free to send me an email or a text, and I will be happy to help you.